Guidance for on-stream and off-stream inspection of separator vessels, best practices for maintaining vessel integrity and safety. Purpose, scope, and applicable codes. This section establishes the purpose and regulatory basis for inspecting separator vessels during both on-stream and off-stream conditions. Separator vessels are critical pressure-containing equipment used to separate oil, gas, and produced water, and their integrity is essential for safe and reliable plant operation. The primary objective of inspection is to ensure that these vessels remain fit for continued service, operate within their design limits, and comply with recognized industry standards. Inspections also aim to identify active damage mechanisms at an early stage so that corrective actions can be planned before failures occur. The guidance presented is based primarily on API 572, which provides detailed practices for the inspection of pressure vessels in service, including both external and internal inspection techniques. API 570 is referenced for principles related to in-service inspection philosophy, corrosion rate evaluation, inspection intervals, and documentation practices that are commonly aligned across mechanical integrity programs. ASME Section 8 provides the original construction rules for pressure vessels, defining design pressure, temperature limits, allowable stresses, joint efficiencies, and fabrication requirements that inspectors must understand when assessing in-service conditions. Together, these codes form a comprehensive framework that supports a life-cycle approach to vessel integrity. Inspectors are expected to understand not only what to inspect, but also why specific requirements exist and how operational conditions influence degradation. This integrated understanding enables inspectors to make informed judgments regarding inspection scope, acceptance criteria, remaining life, and the need for repairs or further engineering assessment. Function, configuration, and key components. Separator vessels are pressure vessels designed to separate multi-phase process fluids into distinct phases, typically gas, oil, and water. They may be configured as horizontal or vertical vessels depending on process requirements, space constraints, and separation efficiency. Understanding the design and function of the separator is fundamental for effective inspection, as different configurations are susceptible to different damage mechanisms and accessibility limitations. Key pressure-retaining components include the shell, heads, and nozzles, which are designed and fabricated in accordance with ASME Section 8. Non-pressure components such as skirts, saddles, and support structures play a critical role in maintaining vessel stability and load transfer to foundations. Internally, separator vessels may contain inlet devices, baffles, weirs, vortex breakers, and demister pads, all of which influence flow patterns and can be sources of erosion, fouling, or corrosion. Inspectors must be familiar with vessel drawings, data sheets, and nameplate information to verify design pressure, temperature, corrosion allowance, and material of construction. This knowledge allows inspectors to correlate observed damage with design intent, assess whether operating conditions remain within allowable limits, and identify areas where damage is most likely to occur due to flow impingement, phase interfaces, or stagnant zones. Responsibilities, skills, and inspection philosophy. The inspector plays a central role in ensuring the mechanical integrity and safe operation of separator vessels. Core responsibilities include planning and executing inspections, identifying and evaluating damage mechanisms, verifying compliance with applicable codes, and clearly documenting findings and recommendations. Inspectors must work closely with operations, maintenance, and engineering teams to ensure inspections are practical, safe, and aligned with operational realities. Competency requirements typically include formal training, relevant experience, and certification such as API 510 for pressure vessel inspectors. In addition to code knowledge, inspectors must understand process conditions, corrosion mechanisms, materials behavior, and non-destructive examination techniques. Sound judgment is essential, particularly when evaluating borderline conditions, unusual damage patterns, or conflicting data. Modern inspection philosophy emphasizes a risk-based and condition monitoring approach rather than reliance on fixed intervals alone. This means inspectors must be able to assess likelihood and consequence of failure, understand historical inspection data, and focus inspection efforts on areas of higher risk. Such an approach improves safety, optimizes inspection resources, and supports informed decision-making regarding continued operation or maintenance planning. Definition, objectives, and limitations. On-stream inspection refers to inspection activities performed while the separator vessel remains in operation and pressurized. The primary objective of on-stream inspection is to monitor the external condition of the vessel, detect early signs of deterioration, and confirm that operation remains within design and safety limits. Because internal access is not possible, on-stream inspections rely heavily on visual examination, indirect measurements, and operating data review. Typical on-stream inspection activities include external visual inspection of the shell, heads, nozzles, and supports, monitoring for leaks, vibration, or abnormal noise, and performing ultrasonic thickness measurements at accessible locations. Inspectors also review operating pressure and temperature trends to identify excursions that could accelerate damage or exceed design limits. The main limitation of on-stream inspection is the inability to directly observe internal surfaces and components. As a result, inspectors must rely on corrosion monitoring locations, historical data, and an understanding of damage mechanisms to infer internal condition. Recognizing these limitations is critical so that appropriate scope and frequency for off-stream inspections can be defined to supplement on-stream findings. External visual inspection and thickness monitoring. External visual inspection is the foundation of on-stream inspection and should be conducted systematically. Inspectors look for signs of general corrosion, localized pitting, coating degradation, mechanical damage, and evidence of leaks at flanges, nozzles, and manways. Particular attention should be paid to areas prone to corrosion under insulation, low points where moisture may accumulate, and areas subject to process upsets. Ultrasonic thickness measurement is a key quantitative tool used during on-stream inspection. Measurements should be taken at established corrosion monitoring locations to ensure consistency and allow meaningful trend analysis. Data should be compared against minimum required thickness values to assess remaining corrosion allowance and estimate remaining life. In addition to direct examination, inspectors should evaluate vessel supports and foundations for corrosion, settlement, or cracking, as support issues can lead to misalignment and overstress. Combining visual observations with thickness data and operating information allows inspectors to develop a comprehensive understanding of vessel condition during service. Definition, planning, and safety considerations. Off-stream inspection is conducted when the separator vessel is taken out of service, depressurized, isolated, and made safe for entry. This type of inspection provides the most comprehensive assessment of vessel condition because it allows direct access to internal surfaces and components. Off-stream inspections are typically scheduled during planned shutdowns and require detailed preparation. Effective planning begins with a review of design documents, operating history, previous inspection reports, and known damage mechanisms. This information is used to define inspection scope, select appropriate non-destructive examination methods, and identify areas requiring special attention. Coordination with operations and maintenance is essential to ensure the vessel is properly cleaned, ventilated, and prepared for inspection. Safety is a critical consideration during off-stream inspections. Inspectors must ensure that isolation, gas testing, confined space entry procedures, and rescue plans are in place and followed. Adherence to safety procedures protects personnel and ensures that inspections can be conducted thoroughly and without incident. Internal visual inspection and damage assessment. Internal visual inspection is a core element of off-stream inspection and provides direct evidence of vessel condition. Inspectors examine internal surfaces of the shell and heads for general corrosion, localized pitting, erosion patterns, and signs of cracking. Particular attention should be paid to areas near the inlet device, phase interfaces, and low points where corrosive fluids or solids may accumulate. Internal components such as baffles, weirs, demister pads, and vortex breakers should be inspected for corrosion, erosion, fouling, and mechanical damage. Damage to internals can affect separation efficiency and may also indicate aggressive internal conditions that could impact the pressure boundary. Findings from internal visual inspection form the basis for further examination, such as targeted thickness measurements or surface NDE. Clear documentation of observed damage, including sketches and photographs, is essential for accurate assessment and future comparison. Ultrasonic testing, UT, magnetic particle testing, MT, penetrant testing, PT, and thickness mapping. Non-destructive examination methods are used to quantify damage and detect flaws that may not be visible to the naked eye. Ultrasonic testing is widely used to measure remaining wall thickness and to perform thickness mapping in areas of suspected or known corrosion. Systematic thickness mapping helps identify minimum thickness locations and corrosion patterns. Magnetic particle testing and liquid penetrant testing are surface examination methods used to detect cracks, particularly in welds, nozzle connections, and areas of high stress. Selection of the appropriate method depends on material type, accessibility, and the nature of suspected damage. Proper interpretation of NDE results requires an understanding of acceptance criteria, measurement uncertainty, and code requirements. Inspectors must ensure that NDE is performed by qualified personnel and that results are accurately recorded and evaluated in the context of overall vessel integrity. Typical degradation in separator vessels. Remaining life, acceptance, and API 579 overview. When inspection identifies wall loss, cracking, or other significant damage, the inspector must evaluate whether the separator vessel remains fit for continued service. This involves comparing measured thickness and defect dimensions against minimum allowable values based on design conditions and code requirements. Corrosion rates derived from historical data are used to estimate remaining life and establish appropriate inspection intervals. When damage exceeds simple acceptance criteria or involves complex conditions, a formal fitness for service assessment in accordance with API 579 may be required. Such assessments provide a structured methodology to evaluate structural integrity and define safe operating limits. Clear communication of evaluation results and recommendations is essential so that operations and engineering can make informed decisions regarding continued operation, repair, or replacement. Repairs, pressure testing, and reporting. When repairs are required, they must be performed in accordance with applicable codes and approved procedures. Inspectors are responsible for verifying that repairs meet design requirements, use qualified welding procedures, and are properly examined after completion. The need for pressure testing should be evaluated based on code requirements and the nature of the repair. Documentation is a critical part of the inspection process. Inspection reports should clearly describe scope, methods, findings, measurements, and conclusions. Accurate records support regulatory compliance, future inspections, and long-term integrity management. High-quality documentation ensures continuity of knowledge and enables trend analysis, risk assessment, and informed decision-making throughout the vessel's service life. Integrated approach to separator vessel inspection. Effective inspection of separator vessels requires an integrated approach that combines on-stream and off-stream activities. On-stream inspections provide continuous oversight and early detection of external issues, while off-stream inspections allow comprehensive internal assessment and detailed evaluation of damage. Adherence to API 572, API 570 principles, and ASME design requirements ensures consistency, safety, and technical rigor. Inspector competency, thorough planning, and accurate documentation are essential elements of a successful inspection program. By understanding vessel design, damage mechanisms, and code requirements, inspectors play a vital role in safeguarding personnel, protecting assets, and ensuring reliable operation of separator vessels throughout their service life.